For this activity, we will be using all of these components that you see here, and we will be building a very complex circuit that uses this new component here, the MusicIC, and we'll be using that to trigger and play sound in a couple different ways. We're going to use all of these components. This is potentially what we might call a messy circuit. We will build this circuit first and walk through each component and how it works in the circuit, and then we will show a simplified circuit and an optimized circuit using pretty much the same components, just less of these snaps here. So to start, we're going to take our battery holder and we're going to put that along the top here on A5 to A7. So that's going to snap right there, so that A5 is the positive and A7 is the negative. Now we're going to introduce this component right here. This is a MusicIC. IC stands for integrated circuit. So there's actually in this little box right here a little circuit board that is already kind of programmed to play music in a couple different ways. So first I'll explain the pins on the MusicIC here. We have down here, we have the negative in this lower corner here. This is what will be connected to the negative of our battery to complete the circuit. Right here up in the middle we have the positive. This is where we'll take the positive of our circuit to feed it some electricity so that it can work. Then over here on the opposite corner of the negative, we have out. This out pin will actually be connected to our speaker, so that whenever it gets a signal to play a song or a sound, it will send that signal out to this pin here, and so we will actually hear it on a speaker that's connected here. Now these two pins up here at the top, we have this one here, which is the trigger. It's abbreviated to TRG. And then we have this one here, which is hold, abbreviated to HLD. And these two will make our music play in two different ways. So with the trigger, whenever it gets a little burst of energy, it's going to signal to the chip to play through a round of the melody. With the hold, it will need a constant supply of energy. So for example, when we hold down this press switch and it closes the connection between the two pins, it will have a constant supply of energy and it will continue to play as long as there is some kind of energy signal connecting to the hold pin. So this plays once when triggered, and this will play while being held. And so this MusicIC, we're going to put this down first in our circuit. And we're actually going to flip it around here so that we have the trigger, positive, and hold kind of along the bottom here, and then our out and our negative kind of along the top. And that is going to go along D7 and D9. So we're going to go D, 1, 2, 3, 4, 5, 6, 7, and D9. So that's going to be the hold right here and the negative on D9, and that's going to snap right down. So then the bottom part here will lie along E7, E8, and E9. So now we are going to continue the first layer of our circuit, and we're going to start next with the whistle chip. The whistle chip here is a little flat component. If you look closely, there are two metal discs inside there, and when electricity is flowing between here, it will actually vibrate those discs and it will act like our speaker. So we're going to use this as our speaker, which means we're going to line it up kind of along by the hold here on the MusicIC. So it's going to go from D6 to F6, and it doesn't matter which way it goes. there is no negative or positive side. And we're just going to snap that down on D6 to F6 so that we got one snap right here kind of lined up with the out in the MusicIC. Next, we're going to put down some snaps to lay the foundations for our circuit. And we're going to start with a 5 rail or a 5 snap rail. And that 5 snap rail is going to go from C5 to G5. So C, A, B, C, 1, 2, 3, 4, 5. And that's going to go straight down to G5. So we're going to snap that down there. This is going to be the positive of our circuit. It's going to kind of come from the battery holder down along here to the bottom. And we're going to continue it along the bottom with a 4 snap. And that 4 snap is going to go from G6 to G9. So G, 1, 2, 3, 4, 5, 6 to G9. And that's going to snap right there, kind of along that bottom. Lastly, for the first layer, we're going to put down a 3 snap rail, and that is going to go from A9 to C9. So A, 2, 4, 5, 6, 7, 9. Right here down to C9. So that's kind of going right above the negative on our MusicIC. You can see we're probably going to connect that there and bring it over to the battery, to the negative side of the battery there. So that's the first layer for our circuit. Now we're going to build up to the second layer. And in the second layer, we will be using our S1 switch and our resistor. We'll be using the resistor as well. And then we will also be using a whole bunch of other snaps as well. So for the second layer, we're going to take our 10K resistor, and we're actually going to place this right on top of the whistle chip so that it kind of restricts the electricity that is being flowed to here. So it actually then kind of vibrates at a lower speed so we can actually hear the sound, but it's not too high or high pitched or impossible for us to hear. So we're going to snap this right on top so that it'll kind of dampen the sound and help the sound flow so that we can hear it well. That's going to go from D6 to F6 right on top of our whistle chip. Next is our S1 switch, and this is the switch that moves from the 0 to 1, 0 being open, 1 being closed. So we're going to leave it on the 0 for open, and that's going to connect the positive of our battery to the positive rail here. So we got A5 to C5. We're going to snap that on there like so. And so we have now a way to control the electricity in our circuit. We're going to leave that on the 0 position so that it is off to begin with. And then we are going to take a 3 snap rail, and we're going to continue along to here in the bottom, and we're going to connect the positive of our IC to this bottom rail down here. So this is going to be E8 to G8. We're going to connect the positive of the MusicIC down to that 4 snap. So E8 to G8. So now we got some positive electricity that's going to come to our MusicIC once we close up this gap over here. Next, we're going to connect our negative of the MusicIC to this 3 snap rail so that we can continue it up into the negative of the battery. So this is C9 to D9, and that's going to snap right on top there, connecting the negative of the MusicIC to this rail right here. And we'll go ahead and finish that off with a 3 snap. So we'll go from A9 to A7, and that's going to snap right on top there. So now we have the negative of our MusicIC connected to the negative of the battery here. A couple more layers to this is we are going to put down a 1 snap, and we are going to put a 1 snap right on top of the out pin in our MusicIC. So we're going to put this tiny little 1 snap, and we're going to put that right on top of the out pin. That way now it is level with our resistor that's on top of the whistle chip, so that in the 3rd layer of our circuit we can connect these two, and it'll be straight across, which will be good. We're going to do 1 along G6 here, so another 1 snap, and we're going to put that on G6 right there. So now that this positive rail kind of down at the bottom will be a little level with our resistor that's on top of the whistle chip. And then next we are going to add our switches for our circuit here. The MusicIC, we can set that aside for now. We have our S2 switch. This is a momentary button switch. So whenever you press down, there's actually a little piece of metal in here that's connecting these 2 pins when you hold down. So we are going to put this on the hold trigger, or the hold snap for our MusicIC, and we're going to connect that down to that 4 rail, because this is going to be our hold input for the MusicIC. So that's going to be E7 to G7. And that's going to get snapped down right there. Doesn't matter which way it goes. There is no negative or positive to that one. And then lastly, for the 2nd layer, we have our fan. We are actually going to use this fan as a trigger, because when you spin this fan, you're actually creating a small amount of electricity in the coils inside, and so that is going to act as a little trigger signal to our MusicIC. And again, it doesn't matter which way it goes, because we're not worried about lighting it up or making it spin. We're using it kind of in a reverse function. That's going to go from E9 to G9. And so that snaps right on there like that. And that is our 2nd layer. Now onto the 3rd layer, which is a whole bunch of snaps. And we have, to begin with, we're going to take a 1 snap, this little guy here, and he's going to go on G5. So G, 1, 2, 3, 4, 5, that's at the end of that 5 rail. We're going to snap that on. So now that we can actually connect these two, because now since we put 1 here, we need to raise this up so that we can have a nice flat connection. So we'll take a 2 snap and put it along that bottom here, the G5 to G6. This is technically a 4th layer, but we're gonna complete that right there. So now that we got that all connected, the last part is we gotta get our speaker hooked up. So that needs to get some electricity to it with the positive, and then we need to connect it to our MusicIC. So we will connect it to the MusicIC with D6 to D7. So we're gonna take this top snap up here and bridge it over to the hold on the MusicIC. And then, actually, I realized we don't want to put that. We don't want to connect that just yet, because we need to put a connection between our whistle chip down to the positive. So we're actually going to connect the positive this way. So we're going to use the bottom rail as our positive to our speaker. So now we got power in our speaker so that when it gets a signal, it can actually make some noise happen. lastly, we are now then going to connect these here. And I'm trying to figure out how he did that. G5. So we're actually gonna take this off and put this on. So we're gonna put a 2 snap rail from F5 to G5. So we're gonna put a little 2 snap there to make that 1 layer higher. Then we'll put on that 1 snap, the G5. So there's a 2 snap from F5 to G5, and then a 1 snap on G5. That way we can get that up a little bit more so that we can finally bridge that little gap right there. And we do that with a 2 snap, and we'll do G5 to G6 with a 2 snap. So you can kind of see there's quite a bit of layers here, but we needed to get that up because we had our whistle chip stacked up with the resistor, and that was stacked, and then we had to make sure that this could jump over, so we have all of these extra snaps lined up. So that's the complete circuit. I will explain now how it works. It uses a lot of components. This is why we call it complex. To start, we're going to give it some electricity by turning on this slide switch. You'll hear it will start the music right away. It's going to play the Happy Birthday tune. And then if we want, we can try out these different pin triggers or pin signals here. We have the hold, so if we hold this, it's going to play, and you'll hear it stops as soon as you let go. So it only plays the sound while you are holding it. And then we have the trigger. So we're going to spin this fan. You only need to spin it a little bit, and it's going to play the whole little melody. So you can see it only takes once to trigger it, and it'll play it all the way through. And then we can interrupt that with the hold. So we can actually interrupt the signal by pressing down on the hold again to interrupt the trigger. So we'll trigger this. We're going to interrupt it. And when we interrupt it, then the hold takes over, and then as soon as we let go, the sound stops. Same if you were to turn it on. So we're going to turn it on. It would play all the way through, but I can interrupt with the hold. That's mostly because it's going to play when it starts that melody IC, that Happy Birthday tune, and when we hold that trigger, it kind of overrides that line, or then gets that signal and is like, oh, you want me to play when I hold it? Okay, I'm going to play when I hold it. So if we do that, and I'm holding it down so it's still playing, but as soon as I let go, it'll turn off. So I can trigger it to play, but I can also tap that hold to interrupt it if I wanted. It doesn't start over though if I'm holding down the button and I'm triggering it because it's already playing. That is how it works. Alright, so now we have our messy, complex circuit, and we're going to ask I'm going to turn this off so it doesn't play. We're going to ask our students or the participants in the workshop to try to simplify it to see if they can get rid of any snaps and still make the system work. One way they can do that is mostly getting rid of a bunch of the snaps. A lot of these components like the fan, the S2 switch, the whistle chip and resistor, and this slider switch, those are all needed for the circuit to work. But we definitely kind of got a messy little mess going on with all of these snaps here. So we can simplify that. Mostly we're gonna snap these off. So I've taken off 3 2 snaps and 2 1 snaps to kind of open up this gap here. And then we can simplify that by simply putting down a 2 snap to close that off. And then you'll notice you could potentially just put a 2 snap and put it onto that resistor there, and now it has the electricity. But we can simplify this even more. What we can do is we can remove the snaps that are connecting the resistor to the positive and to the out pin on our MusicIC. We can take that, we're taking off the whistle chip and the resistor, and we can simply place that over the out pin, which is D7, and onto the positive of our circuit here, which is D5. And if we snap that right on top, we now have a working circuit with a lot less rails. So we've removed at least 3 2 snaps and 3 1 snaps. And so that is how you would simplify the circuit. You can kind of rotate that out of that position so you don't need more snaps, and you can kind of close this off with just 1 snap. So this is the simplified complex circuit. We are working from a simplified complex circuit. Now we're going to move into an optimal circuit. So that would use even less snaps and take up less space. So in order to do that, we're going to have to do some rearranging here. So I'm going to unsnap some of these components. And we are going to line this up along the C and D row. So we're going to do C5 to C7 and D5 to D7. And so we're going to take this negative on the MusicIC and we're going to kind of line it up with the negative on the battery holder. So like that. So now we can simply just take a 3 snap rail and connect the negative of our battery holder to the negative of the MusicIC. So now it has completed the circuit on that end. We didn't have all that extra little bit going down there. Next, we can work on getting the positive kind of laid out. And what we'll do for that is we're actually going to take our 5 rail, our 5 snap rail, and we're going to put that along the F row, spanning from F3 to F7. So that's going to go from F7 to F3. That's going to go along the bottom there. And that way we can then set the components to our MusicIC along there and continue the circuit up. So we got the 5 snap from F3 to F7. And we can go ahead and connect the positive of our MusicIC down to that 5 snap rail. So that would be along C6 and F6, so, or D6 to F6. And then if we want, we can just go ahead and set up our trigger, which is our M7 fan. We're going to snap that onto D7 to F7, like that. And then we'll also take the S2 switch and put that onto D5 to F5. We're going to be using that for the hold pin on the MusicIC. We're going to snap that down there. So now we have the negative hooked up. We got our trigger pins, our hold pins to kind of play the music with. Now we're going to add on our whistle chip. But first we're going to have to lay down some rails up here. So we're going to take the 4 rail, and that 4 snap rail is going to go from A3 down to D3. So A3 to D3, that's going to go along there. And we'll actually then put our S1 switch right there in between that gap so that we can control the electricity flowing from the positive of our battery holder down to the positive of our circuit. And then now you can see we have a rail right across from the out, so we can simply put our whistle chip with the resistor. We can snap that right on top there actually. So we're going to be using the bottom connections, and we don't got to worry about putting anything on the top because we are connected through the bottom pieces there. And then lastly, we'll close off this positive with a 3 snap going from D3 to F3. So you can see we even furthermore eliminated 2 snaps from the simplified circuit, and now we are optimized because it takes a lot less space. It's a little bit more nicely set up with everything aligned, and so it still works. Let's check. It still works. And if we want, we can press this, interrupt that, turn off the music, we can trigger with our fan. If we want to interrupt it, we can, so that it only plays when we're holding the button, and yay. That is the optimal complex circuit for the MusicIC.